Okay, good. So we're about to start the second technical session, which will be about waste status and other regulatory challenges for waste-related algae and materials derived from them. Welcome back. We have 2, 4, 5 speakers again in this session, and then again a question and answer final part before the last plenary concluding session. So I think we're ready to start, and I would like to introduce our first speaker for this session, is Caroline Attat from the European Commission DG ENVI. So I see the slides are ready. Caroline, if you're ready, you can start.
Yes, thank you. Good morning. Well, I would like to mention that this presentation is only a brief presentation. It gives high-level information on the EU rules on waste, byproducts, and end of waste. There is no one-size-fits-all. So considering all the various uses of algae, each situation has to be seen on a case-by-case basis. However, at the end of the presentation, I included additional information and resources for you to look further into. Next slide, please. As I said, there is no one rule to decide whether a substance or an object is waste, or if it's a byproduct, or whether it has ceased to be waste. So a decision on such a classification must be taken on a case-by-case basis by the producer of the substance or the object in discussion with the national competent authorities. And you have to take due account of the scope and rules of the Waste Framework Directive as transposed in the member states' national law. Also, the European Court of Justice cases. Have a look at the cases. I included some examples also in the additional resources, and also looking into the specific factual circumstances of the case, and of course the national procedures, for example, for providing the relevant justifications to the competent authorities. Some countries, for example, require a permit or a decision beforehand, while others, other member states simply set rules, and then the operator decides, and then the authority finally checks afterwards. Next slide, please. I forgot to mention also, when it comes to waste, if I go back to the previous slide, sorry, the definition of waste, the key term here is discard, and it is used in 3 alternatives. It is a substance or object which the holder discards, which is an action or an activity, intends to discard, which is the intention, or is required to discard, which is basically the legal obligation. Okay, the next slide, please. The co-legislators incorporated in the Waste Framework Directive the concepts of byproducts and end of waste, specifically to help to contribute to clarifying what is waste and what is not. So the waste legislation provides conditions against which member states can establish criteria for byproduct and end of waste in accordance with Articles 5 and 6 of the Waste Framework Directive. The directive that amended the Waste Framework Directive, basically Directive 2018/851, made the role of member states more prominent to provide more certainty to the economic operators and to promote a level playing field among the member states. This means that the member states should take appropriate measures to facilitate the recognition of a byproduct, in the case of byproduct, in the case of end of waste, to clarify the waste or non-waste status of substances or objects, to ensure that waste has undergone a recovery operation that is considered to have ceased to be waste, if it complies with the conditions outlined in the legislation. This legislation also lists criteria to ensure a high level of protection of the environment and of health. So have a look also at these provisions. And the next slide, please. Bringing safe secondary raw materials back into the economy is one of the objectives of the Circular Economy Action Plan that was adopted in March 2020. The goal is to get secondary materials up to the level to compete with the raw materials by primarily introducing requirements for recycled content in products. So in this respect, the Commission is now doing a scoping exercise to identify the best candidates for EU-wide end-of-waste criteria for certain waste streams, and potentially also by product criteria. So when carrying out end-of-waste criteria assessments, we must be very mindful of requirements established for products. And risk considerations can be addressed under product legislation. For example, the end-of-waste criteria for compost and digestate from biowaste are outlined in the fertilizing product regulation. So in the work that we are carrying out, first of all, we take account of previous work, the past stakeholder consultations related to the communication on the interface between chemicals, products, and waste legislation. And this particular communication proposes already to have a harmonized interpretation and implementation of end-of-waste rules across the EU. This is to further facilitate the use of recovered material within the EU. So against this background, the Commission launched a study which has been published in 2020 to better understand the member states' practices and as regards implementation and verification of provisions on end-of-waste and byproducts. And I gave a link to the study so you can have a look at it. And the next, the stakeholder, we carried out a stakeholder survey between October and January to extract information from stakeholders regarding data and information linked to this end-of-waste and byproduct assessment. And we are analyzing now the outcomes. And the final slide. Next steps, basically the Commission with JRC will prepare a shortlist of candidates waste and material streams for potential adoption of byproducts and end-of-waste criteria at EU level. These will be based on criteria such as looking at the scale of shipments across the EU, the volume of the waste generated, recovery rates, benefits for health, benefits for society, market viability, success rate. Of course, we need to be certain that the possible future end-of-waste criteria have positive and significant effects on the market. Workshop will be planned later in this year and to feed again into the shortlisting exercise. And then finally, the work on the detailed work on the prioritized list of candidate streams will commence, and it will be based on the JRC methodology. Thank you.
Thank you, Caroline, for introducing this framework, regulatory framework at the beginning of the session. I'm sure there will be questions for you as well in the chat window. Please check the chat window and we will take the questions, of course, also after the end of the list of speakers. So with this, I would like to introduce the next speakers. Next speaker, Floris Schöters from Radius.
Okay, thank you. Good morning, everyone. So at the moment, we are working on a project in which we want to use water that's used to clean poultry stables as a source to grow algae in. In an ideal scenario, we want to use this water, which is legally determined as liquid manure, to grow microalgae, and in return use these microalgae as a part of the feed for the chicken. It's a circular project. However, we have a few problems during this project. Next slide, please. So it already starts with the wastewater as such. In Belgium, you are not really allowed to use it. It's defined as liquid manure. So this is already a problem. Then the second thing is you have to pre-treat the material or the water to remove solids. We don't really know what the status is of these solids. We assume it's determined as manure. Now, what if we are allowed to use the wastewater? What kind of parameters do we need to check for? We envision, for example, heavy metals, presence of toxins, bacterial pathogens. And it becomes even more complex. What if you want to incorporate rain or groundwater in the system? Imagine we are allowed to grow the microalgae in the wastewater. What would be the status of the water after you grew the microalgae? Because most of the nitrogen and phosphorus is removed. So is this water still considered liquid manure, or are we, for example, able to drain the water in the sewage if we, for example, have to check a few parameters? Next slide, please. But more importantly, of course, is the status of the algae itself. We want to use these algae as a commercial product, or at least an upvalued product? For example, can we use it as animal feed, as fertilizer, or as a biostimulant, or maybe even as food? In order to know more about what we can do with these microalgae, we need to know what kind of parameters we need to check for the quality and the safety of the material. There are a few lists of microorganisms to be checked, but legally there is still a vacuum here. It's not very clear. Also, what type of pollutants do we need to check for? As I already mentioned, for example, heavy metals, but maybe also other pollutants like antibiotics, but maybe or might be used for the chicken. What about toxins? Fungal toxins, for example, or histamina. All these things we are not very clear about what we have to check. And then also, even more importantly, at what stage do we want to, or do we have to check for these things? In the liquid phase, when it's still in a watery composition, or maybe after we centrifuged the algae and we separated most of the liquid phase, or in case we dry the algae, do we have to check also in the end for the dried end product? So these are all kind of questions we hope to find an answer for. Our research so far has shown that it is actually possible to grow the microalgae in this wastewater, and that you end up with a product that is comparable with a microalgae product grown in clean water. So thank you for your attention.
Thanks to you, Loris.
Yep.
And then we can move now to the next speaker, Claudio Fuentes Grunewald. He will introduce the Algae AD project from Swansea University, UK.
Okay, thank you very much for the invitation to this webinar. I will present to you, this is a short presentation of what we have done at Algae AD project. Next slide, please. So basically the idea is try to use the digestate produced from AD plants in order to incorporate as a nutrient source for microalgae production in different facilities in Europe. We have 3 different facilities, and the idea is to create value from waste nutrient by integrated algae and anaerobic technology. What we have done that is because there is a legislation of nitrogen vulnerable zones in the EU, and there is an excess of this nutrient, especially ammonium and phosphorus, and the idea would be to treat these nutrients by using microalgae biotechnology. As I said to you, we have implemented 3 large-scale pilot facilities in the EU and the UK, and after the microalgae biomass production and after the bioremediation of this nutrient, we were able to produce biomass, and this biomass will be used for piglet trials and fish trial, and especially we have done an enzymatic hydrolysis for the purpose of feed production for this animal. Next slide, please. Okay, as you can see here, there are 3 pilot facilities, one in England, South England, in Plymouth. In this facility, we have commissioned a 7-ton photobioreactor where we do 2 type of production. First, in the autotrophic phase, we bioremediate, and then in a second phase, we use mixotrophic cultivation in order to boost the biomass concentration and to provide with a high quality protein content. Then we have in France, Cooper. In Cooper, this is a company that is one of the biggest pig producer in France, and in this case, we have used, or our colleagues from France have used heterotrophic mixotrophic approach using Trisocidium in order to grow the algae by using the digestive produced from pig manure. And then finally, we got in Ghent University, in this case in INLO lab, we have set up autotrophic cultivation of 2 different systems, one vertical system and one horizontal system, and using specifically a digestate produced from agricultural waste. Next slide, please. This is a summary of the result of these 3 pilot facilities. As you can see, we have been able to uptake ammonium specifically, and the tricky situation here was that the AD plant, they treat different waste. So for instance, in Plymouth is mainly household organic waste, copper is pig manure, and in lab is plant-based feedstock. So the idea was to use a different digester in order to have a clear overview of all the AD facilities in Europe. As you can see as well, we have treated or pre-treated the raw digester in a different manner. For instance, in language, we have used membrane filtration, mainly microfiltration, in order to treat this digester before to put into the photobioreactor. In Cooper, they have used tangential flow, which is roughly the same, but in this case was ultrafiltration. And in Hydrolab, they have used paper filtration and UV sterilization. Next slide, please. So what the results? So we have obtained high concentration of protein, pigment, and fatty acid in this material. We have obtained over 70% of protein content, which is good for animal production. Of course, we cannot compete with soy protein based, but there are other kind of advantages using the biomass. And we will see later on the results of this big trial by the end of this year. Also, we have performed an hydrolyzation step in order to release all this protein and to be more palatable and more easy to uptake by the pigs. This is a key element here. According to our safety analysis of digestate and algal biomass during the process of the raw digestate, the pre-filtration system, the biomass, and after harvesting, we have found no harmful bacteria such as Clostridium or E. coli, so which is pretty good because it's quite safe, and we can say clearly that by using this technology, we avoid, specifically by microfiltration and ultrafiltration, we avoid this kind of pathogen. And next slide, please. Basically, yes, there are no specific. The problem is that technically it's feasible to do that, but we don't have the legal framework in the EU in order to do this. So there is no specific framework. There is provision to use in animal feed for the most common, and digested from plant-based inputs can be used to cultivate microalgae. Despite the treatment of digested nutrient converted into microalgae, the safety analysis indicate no harmful pathogen or contaminant, which is a pretty good result. Next slide and final. Thank you very much. And if you need any other information, please contact us in those links. Thanks.
Thank you, Claudio.
Mm-hmm.
So we have two more speakers in this session, and then it's question and answers time again. The next speaker is Robert Reinart from Algae Technology Center in Slovenia.
Hi. I will be super brief as most of what I intended to tell was already told. So I will just present our ongoing project on wastewater conversion or utilization of wastewater to produce agricultural products. Next slide, please. Water to Return is a project that has been running for 3 years now, with quite some parts that are dealing with algae and some parts not dealing with algae. Here is the general schematics of the demo site in Seville, Spain. That actually, if you just see, the main structure is basic water line to treat water from the slaughterhouse. This water line then spins out two streams. One is sludge for Bacillus subtilis fermentation, and the other one is sludge, anaerobically digested sludge that is used for algae cultivation. All three products are intended to be used in agriculture applications, and the field testing on large scale, like I think 10 hectare scale, has just been started this month. Next slide, please. Well, of course, the consortium is large, and the most important part is the demo site in Seville. Next slide. Just a few pictures of the site to have an impression. Next slide, please. The regulatory issues are mostly those that were already discussed. Inclusion of cyanobacteria in the agricultural fertilizer of biostimulants products seems to be an issue, because I mean, not that we grow cyanobacteria, but they are grown by itself in open ponds. We don't specifically inoculate the ponds with cyanobacteria, but there surely are. And now the partner the partner producing biostimulants is right now using this as a competitive advantage, that most of our material is of algal origin and not cyanobacterial origin, but somehow that's not all the truth. That is all that I wanted to say, and for any questions, I'm open here. Thank you.
Thank you for the perfect timing. So I think we can now move to the last presentation of this session, and it will be Silvio Mangini from Archimede Ricerche.
Thank you. Good morning, everyone. Thanks ESPP and the ABA for invitation. I take 2 minutes to show you the outcomes of Algae project and H2020 consortium dealing with food wastewater recovery with algae. Next slide, please. 3 demo facilities were organized under this project, namely one in Italy to grow algae and perform phytodepuration of dairy wastewater, which is a case where regulatory issues are managed through the byproduct topics of existing environmental national regulation, providing I would say the common sense balance of byproduct. A byproduct must originate from a process being integral part of such process, and this is the case of dairy washing water, because in the food industry, dairy washing water is made only up of milk and pure water, so it is not dangerous. The byproduct must be utilized, and this is the case of washing water using as a substitution nutrient medium for spirulina, and in the end, it must meet all relevant requirements about health and environment, which was the case of this kind of demo. So the nitrogen and phosphorus removal was effective, and in many cases, it was necessary to compensate for missing nutrient according to red field ratio. Next slide, please. Next slide. Thank you. The second demo was in Israel, and it was a good example of IMTA, which is integrated multi-trophic aquaculture, because microalgae, namely spirulina, was grown in the wastewater coming out from fish tanks in order to clarify and treat this kind of wastewater by removal of nitrogen and phosphorus. And you can see in the graphs that this is very effective, and by getting cleared water which was used for irrigation purposes. The third facility was in Slovenia and was to treat slaughter warehouse wastewater, and in this case the biomass was not of good quality enough to be used for feed purposes, as was the case of dairy wastewater. Thank you, and I am available for questions.
Thank you, Silvio. I think this was the last presentation of this session. So, Lapo, can you please switch? Okay, fine, because the closing session will start later. In the meantime, our rapporteurs also for this session, Thomas van Necke from Flemish Coordination Center for Manure Processing and Renske Verholst from the Netherlands Nutrient Platform are collecting the highlights and the findings of the breakout session, as well as the rapporteurs of the previous session. So they will wrap up, prepare some summaries that they will present in the closing session. So now we have like 10 minutes for questions and discussion. So I would like to open again the floor to panelists and speakers. Chris, if you saw anything in the chat window that deserves attention, please go ahead.
Maybe to come back on what Caroline said about the Commission launching work to define end-of-waste status, European end-of-waste status for certain sectors or materials. So there's already been a bit of discussion in the chat, but that might be interesting to look at where there's certain forms of algae production from using waste materials growing on manure or other secondary materials could be considered for that kind of end of waste status. Obviously, that would be additional to the quality criteria required for use in food or feed, but it would certainly clarify things maybe for the sector if it knew that under certain conditions and quality conditions, waste grown algae could have clear end of waste status. Is that something which is feasible, or is that too wide a definition of a sector to be sensibly considered?
Thank you, Chris. At the moment, also considering it's still relatively new, we still need to collect much more information from the stakeholders in order to be able to reply to your question. I doubt at the moment, the streams we are looking into are not obviously related to the topic we're discussing today, but it doesn't mean that in the future we will not. But to do this, we need, as I said, more information. But to give you an idea of streams we are looking at, these are not fixed in stone, but just an idea. So end of waste for textiles, end of waste for packaging and electronics, construction and demolition waste. These are the sort of waste streams we are looking into at the moment, because we have gathered a lot of information at this point. So I suggest that you keep up discussions like this to learn from each other and share best practice, and also to discuss with the national competent authorities. As I mentioned, it is important at this stage for member states to set this sort of end of waste criteria, and then they would make contact with us, and where we see that there is a big market, or as I mentioned, criteria, volumes of waste, or the other criteria I mentioned earlier, then we will look into developing criteria for algae. Of course, it takes a lot of time to develop even just one end of waste criteria for one waste stream. So we really need to, at this point, carefully choose which ones to set at EU level.
So maybe if I can come back on that. So if I think this is a good forum to say, yes, you're looking for information to justify possibly looking into end of waste status. What sort of information are you looking for? Is it market? Is it quality? Is it definitions?
All sorts, anything.
Sorry,
anything.
can I just, the second question is, do we submit that directly as industry or does it go through member states?
As I said, that ideally first you go to the national competent authorities. At this stage, it is early for us to look into this type of waste stream. So I first go to the national competent authorities, and they should, based on the conditions and the criteria outlined in the Waste Framework Directive, then develop end of waste criteria themselves. So first hold discussions at national level, and then in the future, through discussions in our expert group, we will then see where the need is to have end of waste criteria at EU level. All sorts of information is important: the quality, the safety, the technologies that are used to remove the contaminants, for example. All relevant information is important on the process. So I cannot tell you would you need this type and not the other type of information.
Thank you. That was very clear.
May I?
Sure, please go ahead.
Well, my suggestion here would be to somehow, I mean, based on the experience that we have in algae growth on cleaning waters, there are some categories of waste, like cleaning water is in certain industry that have a very defined composition. I mean, it's always the same. I mean, in this particular case that Silvio was talking about, it's milk and 2 cleaners. Something like that should be relatively easy categorized for end of waste directive. The problem is that it now depends solely on the national authorities. In Italy, that was a simple procedure as demonstrated by Silvio. A try here in Slovenia was super complicated and no understanding was there. So I'm in these particular cases, I would somehow like to see some kind of general European approach, and because for any kind of products that you want to sell, you need to have certain margins where you can sell this. That's the approach that we are lacking a lot.
Thank you, Robert. Are there any other questions or comments from the panelists? Chris, do you think we have other, from the chat window, any other general questions that we could raise?
I'm trying to look at them. I think the previous question was interesting, and maybe what would be useful would be to have indeed some kind of inventory of which algae-derived materials from wastes already have an end of waste status in one member state somewhere. Because as Caroline said, the first move towards asking for an EU end of waste status is to have it obtained in one or more, preferably more, member states who will then support it at a European level. So that is maybe something that we can work on with the EABA.
Good. So I'd just like to remind you can still put your questions or comments in the chat window. If yours is not answered, they will stay. I think they will be saved also as the slides and the video, so you can find them later. I think we can now move to the conclusion of this session. And if we have some spare time, I think we could leave it for the rapporteurs that are now summing up, wrapping up everything. They will, I presume they will need some time to put together the highlights and the findings of the two technical sessions. So if you agree, we can stop here this session and meet again at 12:15 sharp for the closing session, where we will have three more technical presentations and then the final summary of the two breakouts. So thank you again for staying with us throughout all the morning. Meet you at 12:15 sharp. Thank you.